This lecture deals with DDA line drawing algorithm, that is digital differential analyzer algorithm. So if you take any line drawing algorithm, it will receive two parameters, the first endpoint and the second endpoint. So that will be in the form of Cartesian coordinate x1 y1 pair and x2 y2 pair. And the aim of line drawing algorithm is to determine the intermediate points that lies along the line path between x1 y1 and x2 y2. So this is the case. You are having first endpoint x1 y1 and you are having another second endpoint, that is x2 y2. So aim of line drawing algorithm is to determine the intermediate points along the line path between x1 y1 and x2 y2. So in our context, the aim is to determine the pixel position that lies along the line path between the endpoints x1 y1 and x2 y2. So if you take line drawing algorithms, it proceeds based on the slope intercept equation y equal to mx plus b, where m is the slope and b is the y intercept. So m is defined as delta y by delta x, that is equal to y2 minus y1 by x2 minus x1, y difference by x difference. So first we can consider the line with positive slope. So this is actually a line with positive slope. This is x1, this point is x2, point is y1 and this point is y2. So this is the y-axis and this is x-axis. So if we consider x difference, that is delta x and delta y, it is somewhat clear that delta x is greater than delta y. Delta x is greater than delta y. So we are first considering line with positive slope. And delta x is greater than delta y. If delta x is greater than delta y, then in DDA line drawing algorithm, just sample x at unit intervals. So you have to sample x at unit intervals and determine the corresponding y values based on the slope intercept equation. So the reason is that if you sample x at unit intervals, you will be getting maximum number of intermediate points between the endpoints. You will be getting maximum number of samples so that you can determine the corresponding y values. So if delta x is greater than delta y, x is sampled at unit intervals and the corresponding y value is computed using the equation y is equal to mx plus b. So that is the basic idea. So if current x value is 10, then the next x value will be 11, then the next x value will be 12, and this will be incremented until the x value reaches x2. That is the basic idea. And this happens if delta x is greater than delta y. Sample x at unit intervals, determine the corresponding y value from the slope intercept equation. That is the basis. Then what happens if delta y is greater than delta x, or delta y is greater than delta x? So let this be the situation. Let this be the second point, x2, y2. this will be the line, this will be the endpoint x2. So this is delta x, and this will be, this is y2, and this will be delta y. From this it is clear that x difference is less than y difference, in the sense y difference is greater. So if this is the situation, sample y at unit intervals. So if delta y is greater than delta x, y is sampled at unit intervals, y is sampled at unit intervals, and determine the corresponding x value from the slope intercept equation. So from the slope intercept equation, it is clear that x is equal to y minus b by m. That is, if the current y value is 10, then the next y value will be, so for this y value, determine corresponding x value using this equation. Then increment y by 1. So next y value will be 11. For y value 11, determine x value using this equation. Then increment this y value, it will be 12. For 12, determine the corresponding x value using this equation. And so on until you reach y2. So this is the basic idea behind DDA line drawing algorithm. Now what happens, again, what happens if delta x is equal to delta y? So if delta x is equal to delta y, then x difference is same as that of y difference. You can either sample x at unit intervals or you can sample y at unit intervals. So for the time being, you will be sampling y at unit intervals. So you can take the general policy for positive slope line. If delta x is greater than delta y, sample x at unit intervals and determine the corresponding y value. And if delta y is greater than or equal to delta x, sample y at unit intervals and determine the corresponding x value using this equation. Now what happens for a line with negative slope? So let us consider this line. So this is the first endpoint y1, this is the second endpoint y2, because we are moving from left to right. So this is x1 and this is x2, and it is pretty clear that x2 minus x1, that is delta x is positive, and what about y2 minus y1? y2 minus y1, this will be negative. So this is positive and this will be negative. So delta x is positive and delta y is negative. But if you consider the actual x difference and y difference, x difference is greater. So you can follow the strategy, sample x at unit intervals and determine the corresponding y value using the slope intercept equation. So what happens if you are considering a line with slope like this? You can consider this particular line. So this is x2, this is x1. This is the first endpoint, this is the second endpoint, and this is y1 and this is y2. And if we consider x2 minus x1, that is positive, x2 minus x1, that is positive. And if we consider y2 minus y1, that is negative. But if we simply compare delta x greater than delta y, that gets satisfied because delta x is actually positive and delta y is negative. So if you compare delta x greater than delta y, this condition gets satisfied and you will go on sampling with x at unit intervals. But if you consider the actual magnitude, if you sample x at unit intervals, you will be getting a lesser number of samples as compared to this one, because if you take the magnitude of delta x and delta y is greater, that is magnitude of y difference is greater than that of x difference. So if you sample, in this case if you sample y at unit intervals, you will be getting more number of samples as compared to x direction. So we can extend this particular policy. If modulus of delta x is greater than delta y, then sample x at unit intervals and determine the corresponding y value using this equation. Again, else if modulus of y is greater than or equal to modulus of delta x, modulus of delta y is greater than modulus of delta x, then sample y at unit intervals and determine the corresponding x value using this equation. So this is the basic idea behind DDA line drawing algorithm. It's purely based on slope-intercept equation. Now let us formalize this method and how to determine y value for corresponding each x value and how to determine x value incrementally for each y value. So first you can consider, so this policy will work for line with positive slope and negative slope. Now first you can consider modulus of delta x greater than modulus of delta y. So in this case you have to sample x at unit intervals. So assume that at kth step we have plotted the point xk, yk. So at some point at kth step we have determined the corresponding pixel position xk, yk. So and this particular point will satisfy the equation yk is equal to mxk plus b, because xk, yk is on the line path. So it will satisfy the slope-intercept equation. Now at k plus 1th step, what about the next x value, xk plus 1? Since we are sampling x at unit intervals, at k plus 1th step, the new x value, xk plus 1 will be equal to xk plus 1, because we are incrementing x by 1. We are sampling x at unit intervals. Now how will you compute xk plus 1? That is, what about the yk plus 1? That is the y value associated with this particular x value. So yk plus 1 will be equal to m into xk plus 1 plus b. So this will be equal to, so what about xk plus 1? Xk plus 1 is xk plus 1. So m into xk plus 1 plus b. So this will be equal to mxk plus m plus b. So you can rewrite this equation as mxk plus b plus m. So what is mxk plus b? Mxk plus b is actually yk. So this will be equal to yk plus m. So that is the beauty of this technique. Rather than performing this multiplication m into xk plus 1 at each and every step of computation, you can incrementally calculate the next y value from the previous y value. So if you are sampling x at unit intervals, the next x value will be the previous x value plus 1, and the next y value will be the previous y value plus slope. So that is the main point. Now what about the else part? That is modulus of delta y greater than or equal to modulus of delta x. So if this is the case, you have to sample y at unit intervals. And assume that at kth step we have plotted the point xk yk which satisfies the slope intercept equation yk equal to mxk plus b. Now at k plus 1th step, what about, since we are sampling y at unit intervals, what about the next y value, that is yk plus 1? Since we are sampling y at unit intervals, the next y value will be previous y value plus 1. So that will be yk plus 1. Now what about, how will you compute the next x value from this equation? So you can rewrite that equation as yk plus 1 is equal to, sorry, xk plus 1 is equal to yk plus 1 minus b by m. So we can determine the next x value from this equation. So that is based on this formula, transformation. So in this case, this will be equal to, what is yk plus 1? Yk plus 1 is yk plus 1. So yk plus 1 minus b by m. So I can rewrite this as yk minus b by m plus 1 by m. I am grouping yk and b. So yk minus b by m plus 1 by m. So what is yk minus b by m? So from this equation, what is xk? Xk is equal to yk minus b by m. So yk minus b by m is xk. So this will be equal to xk plus 1 by m. So here also we are eliminating this division operation, which is costlier as compared to addition or subtraction. So if modulus of delta y is greater than or equal to modulus of delta x, sample y at unit intervals and determine the corresponding x value incrementally from the previous x value. So if we plot xk yk at kth step, next point will be computed like this. So I can say that next point will be xk plus 1 by m yk plus 1. That is, y value get incremented by 1 and determine the corresponding x value incrementally like this. So in this way DDA line drawing algorithm works, and this will work properly for line with negative slope also. So what happens if line is having negative slope? So before that, let me summarize the points. If modulus of delta x is greater than modulus of delta y, then next point is xk plus 1 yk plus m. Okay. Else in the sense modulus of delta y is greater than or equal to modulus of delta x. Next point is xk plus 1 by m yk plus 1. Now let us consider line with negative slope like this. So this is x1, this is x2, this point is y1, this point is y2, and it is clear that this is delta x and this is delta y, and here delta y is Yeah, delta y is negative, and that is y2 minus y1, that is negative, and delta x is positive, right? So in this case, if you consider modulus of delta x is greater than modulus of delta y. So you are sampling x at unit intervals. So if you sample x at unit intervals, assume that at kth step you are plotted xk, yk. What about the next point? Since we are sampling x at unit intervals, next x value will be xk plus 1. What about next y value? So if we initially assume that you have plotted this point, so if we consider the next y value will get decremented as we move from left to right. So, and from this case, if you take delta y by delta x, you will be getting slope which will be negative. So m value will be negative. So this will turn to yk plus some negative value. So that negative value will be minus m. So in this case, if we move from left to right, x get incremented by 1 and y get decremented by the value of slope. So this strategy will work for line with positive slope, negative slopes, with modulus of delta x greater than delta y, or a modulus of delta y greater than or equal to modulus of delta x. Again, let us consider horizontal line and vertical line. So let this be the horizontal line. You are having x1, you are having x2, and if you take y1 and y2, both are same. So what happens if we consider delta x? Delta x is actually greater than delta y, and delta y is equal to 0. So in this case, if you take a slope will be equal to 0. That is delta y by delta x, 0 into 1 by delta x, that will be equal to 0. And since delta x is greater than delta y, at each and every step you will be incrementing x by 1, and the next y value will be previous y value plus slope. So that is previous y value plus slope is 0. So in this case, in order to plot this line, you need to increment x by 1 and keep y stationary. That is, you don't need to change the y value. Y value will remain same and x get incremented by 1. Now, what about vertical line? So that is actually symmetric to horizontal line. If you take this is x1 and again this will be x2, delta x will be equal to 0. So let this be x1, this will be x2, sorry, y1, this will be y2. So delta y is positive. So delta y by delta x, that is actually, there exists a particular issue here. If you take the slope will be equal to delta y by delta x, which is equal to delta y by 0. This may lead to division error. So how will you solve this issue? So actually, if you consider this particular case, it is clear that modulus of delta y is greater than modulus of delta x. So you are expected to sample y at unit intervals. So you have to take this particular point y at unit intervals, and you have to keep x stationary for each y value. Keep x as x1 or keep x as x2, since x1 is equal to x2. That is the strategy to be followed if you consider vertical line. So now let us consider the formula algorithm. So as I said, this line drawing algorithm receives parameters x1, y1, x2, y2, the line endpoints. So the first point is it has to compute dx. Dx is equal to y2 minus y1, dy equal to, dx is equal to x2 minus x1, dy equal to y2 minus y1. Now, as I said, how to check if absolute value of dx greater than absolute value of dy, that is magnitude of dx greater than dy, then you have to take a variable, let it be steps. Steps is equal to absolute value of dx, else steps is equal to absolute value of dy. Now after fixing the steps, you have to determine x increment. X increment is equal to dx by steps, and y increment is equal to dy by steps. Now you have to plot the set pixel. Assume that set pixel is the function that actually plots the point. So set pixel x1, y1. So you have plotted the first point. Now you have to determine the intermediate points between x1, y1 and x2, y2. That is, you have to iterate delta x times or delta y times. That is there in steps. If delta x is greater than delta y, steps will be delta x, and otherwise steps will be delta y. So for I varying from 1 to steps, do the following. You have to compute the new x value. X is equal to x plus x increment, and y equal to y plus y increment, and you have to set the pixel, set pixel xy. As I said, set pixel is the function that actually plots the point xy. Now let us consider this particular line with or you can consider vertical line. So here delta x is equal to 0 and delta y is positive. Delta y is positive. So what happens is, at this point it will be checking modulus of delta x greater than delta y. Condition fails. So steps will be equal to dy, and you will be computing x increment. X increment is equal to dx by steps. So 0 divided by dy. So this will be equal to 0. And what about y increment? Y increment is equal to dy by steps. So dy by steps is dy by dy, that is equal to 1. So if you consider this particular vertical line, at each and every step x get incremented by 0, it will remain same, and y value will get incremented by 1. Now what happens for a horizontal line? In this case, delta y will be equal to 0 and delta x, let it be a positive value. It will be greater than 0. So in this case, since delta x is greater than delta y, steps will be equal to absolute value of dx. So it will be getting that magnitude. And what about, so it will be dx. What about x increment? X increment is equal to dx by steps is dx, so dx by dx will be equal to 1. Now what about y increment? dy by steps, so dy by steps is dy by dx, which is actually equal to 0. Delta y is 0, 0 by steps, which is equal to 0. So in this case, x get incremented by 1 and x get incremented by 1 at each step, and the y value will remain 0 because y increment is 0. Now what happens for line with negative slope like this? So assume that this is y1, this is y2, this is x1, this value is x2. So this is delta x and this is delta y, and assume that delta y is negative. Delta y is negative. And again, if you consider modulus of delta y, modulus of dy, that is greater than modulus of dx. This condition, this difference is lesser than this difference. So what happens is, what about the value of steps? So this, since this condition is satisfied, steps will be getting absolute value of dy. So you are not taking the negative value, you will be taking the positive value. So here you will be getting dy, that is absolute value of dy. Now what about x increment? X increment is equal to dx by absolute value of dy. So dx by absolute value of dy will be equal to 1 by m. If you are not taking absolute value, this will become minus 1 by m. Now what about y increment? Y increment is equal to dy by steps. So dy is negative, dy by modulus of dy. Steps is modulus of dy. So this will be equal to, dy is negative, so this will turn to minus 1. So as I said earlier, in this case x get incremented by 1 by m and y get decremented by minus 1 at each and every step of iteration. So this works properly for all cases, that is line with positive slope, negative slope, vertical line and horizontal line. Then what is the advantage of this algorithm? This algorithm actually eliminates division operation. So here you are not performing any, at this point you are performing division, but in the actual iteration process you are using only increment operation. You are not performing any division operation or multiplication operation that actually become faster as compared to other operations. So this algorithm is faster since we have eliminated, or this algorithm eliminates costlier operations like multiplication and division operation. Then another, that is one advantage of this algorithm. There is some drawback. One drawback is that if you compute dx by steps, x increment and y increment, that need not be an integer value. So that will be some, that value will be some floating point value. So it is not possible to plot pixel like this. So 10, 7.5. You cannot plot pixel like this. So you have to round it up. So you will be getting 10, 8. Okay. So after computing x increment and y increment, at each and every step you will be computing the xy values by adding x increment and y increment to the previous x and y values. After computing x and y, you have to plot the pixel after rounding up x and y. So if the resultant x and y remains turns to a floating point number, just round it up and plot it. So a repeated round of operation will sometimes drift the pixel positions from actual line path up or down. So it actually drifts the position of actual positions of pixel from actual line path. That is one drawback of this DDA line drawing algorithm. And again, here you have to perform. We have not explicitly mentioned the rounding up operation. As I said, this x increment and y increment need not be an integer value. It could be a floating point value also. So that actually leads to determine or leads to the computation of xy values that sometimes turns to be floating point. So if you are having floating point values for x and y, then you have to round it up. So you have to, or this algorithm must have to spend some time on rounding up operation. That is little bit costlier. So some time will be spent for rounding up operation if you consider DDA line drawing algorithm. That is one drawback. Actually, we are plotting pixel, the first endpoint x1, y1. So before plotting this pixel, you can assign x is equal to x1 and y equal to y1, and then set pixel xy, so that this x and y will be having the initial endpoint x1, y1. So you need to initialize xy before entering into this iteration process. That's it.